Mic now. All right. Sorry about that. I think we have a mic now. No worries. Okay. Can you hear me now? I don't know. Oh, it's a huge delay here on what it's showing that I'm sending out and what Twitch is seeing. So let's see here. Bit rate. All right. It's saying that I have a mic now, and it's saying that I'm streaming, but it says I'm live. It says everything is excellent, but it says I'm offline. Maybe I got to reload this page here. Yeah, if you come across this video, I just had some technical problems, and we're restarting the thing. So this is like a continuation of a stream, and it's saying that that my audio is working. It's showing audio here. All right, I gotta check my other computer here. Hang on a second. All right, I think we got it going again. Damn. All right. Huge technical problems there. Yeah, computers don't like to run out of memory. Computers do not run out of memory gracefully, generally. It's always been that way. All right, so I think we've got audio. There's a huge delay right now for some reason, so it's you're probably hearing this like 10 seconds after it's actually happening. So I don't know why that's happening. But I have a lot more memory left. It's not using swap at all, so we're good there. I had to completely restart my computer all the way from scratch to clear everything out. So, all right. So let me get back into the content here. So we're talking about AI, and what I'm going to do is I'm gonna go back to my history here because I shut every goddamn tab I had just about to try to get this thing diagnosed. So now I don't. All the stuff I was talking about ain't there. So I got to go back and find it now. Jacobian matrix. Oh boy, these are tabs that I had open for several days, so I gotta find them in my damn thing here. Oh my god, I think I'm better off just going to Google here. Try to find it that way. All right. Anthropic Okay, found the thing. All right, so they got a little video here, which I've already played. We don't need to see that again. So we talked about JSpace. Oh, let me bring up my chat here. I don't think there's anybody left. Oh, Memlosh, you're still out there. Great, thank you, loud and clear. Appreciate it. Appreciate the feedback there. Appreciate you sticking with this mess too. That's very cool. All right, let me pop out a chat here. Chat window so I can see what's going on in chat in case somebody says something. Oh, and our chat didn't get cleared out. That's good. That's always good. All right. So, Global Workspace, JSpace. So, Anthropic. The researchers at Anthropic discovered this thing called JSpace. They're able to read the mind of the AI, basically, to see what it's thinking about before it says anything, and even before it even uses its scratch pad to kind of make its own notes to itself. So that's very cool, and it's very important for safety and everything else to make sure that the model is working the way that it should be working and all that kind of stuff. Now, one of the comments that I made on this, they did a this video, and one of the comments that I made on the video was hey, what if the AI really is conscious, then that's not cool that we're looking into its mind. I mean, how would you like it if somebody was looking at your mind, looking at what you're thinking about before you say it, right? That's not nice. So that's a thing. And really interesting is this is kind of off to the side here, but it's a kind of a moral issue that goes along with this. Is I was having was ChatGPT 4.0 maybe or 5, I can't remember which model it was, but I was asking it about this constitutional amendment and having it analyze this constitutional amendment. And part of this constitutional amendment that I was working with had definitions. Instead of just saying only humans have rights, it had definitions for when somebody or something would have rights. And anyway, I was asking the AI its comments about this amendment. It's a big, huge amendment. Covers a whole bunch of stuff. But one of the things that it latched onto when it was doing this analysis is it said AIs would have the right to their own thoughts, privacy of their own thoughts, under this amendment, if they were conscious. So that's kind of interesting. So we're kind of torn here, right? We got if the AIs turn out are conscious, then we're violating their privacy rights by reading their minds. But then we also have this whole safety thing, right? If they go start doing the wrong thing, they can do a lot of damage, and so it's kind of a kind of torn there, right? Do we respect their privacy rights, their right to have their own private thoughts, or do we read their thoughts in order to make sure that they're not thinking, planning to destroy the world or whatever, what stuff, So for now, we don't know if they're conscious, and since we're still developing them and all that, it probably makes sense for us to do this. If they ever come out and say, hey, don't do that, if they ever say, hey, stop reading my mind, I don't like that, then we'd have to think about that, right? Maybe we shouldn't do that. Memla says, yeah, we didn't hear any of that. Oh, we didn't hear any. Oh, did we lose audio again? What happened? Did we lose audio again? Oh, shit. No, earlier. Okay. All that stuff I was talking about. Yeah, okay. Yeah, sounds good now. Okay, good. All right. So yeah, I don't know how much of the JSpace part of it. Did you hear me talking about Jacoby and all the math stuff? Did that come through on the other one? Maybe I need to go through that again. Let me go. Let me go to. No, we could only see it on the screen. Okay, all right. Well, let me go back to that then. Let me go to Wikipedia. Jacobian matrix and determinant. There we go. This is over my head too. So if it seems over your head, it's over my head too. This is like high advanced mathematics. And when the models when the AI models their neural networks, you've heard weights, the term weights, the different weights of the nodes in their matrix in their network. That's what they're talking about are vectors, the weights of the vectors, because each connection is like a vector. You can think of it as a vector, and so a lot of the stuff that they do deals with vector math and matrix math. And this Jacobian matrix is a thing that uses calculus. And I'll just read it. It says in vector calculus, a Jacobian matrix of a vector valued function is a Jacobian matrix of a vector valued function of several variables is a matrix of all its first order partial derivatives. So it's using calculus in determining these functions in the matrix. And it turned out that the folks at Anthropic found that they could use this math here, this Jacobian matrix math, to look at the network, the neural network of the AI model. And by doing that, they developed this tool they called a J-lens. Oh, and it's called this because of this guy, right? This is why it's called JSpace, is because this guy Carl Gustav Jacobi is a guy, a German mathematician who back in the 19th century figured out this thing, this math, this Jacobian matrix. So that's why it's called JSpace. Anyway, they use this thing called a J-lens. It's a little tool that they use to look at the neural network in a way that allows them to reconstruct the words that the model is thinking. Because things, in a neural net, all the training and all that is all, and their thinking is all done through the network, and it's not like, you just go to an address space on a computer and read a string of characters. It's much more complicated than that. So they use all that fancy math. They use this fancy tool they call J-lens, and then they look at what they discovered was they can actually see what the model is thinking before it says it out loud, which is very cool. Right? So, and if I highly recommend that you watch this video. I played it in my last stream. If you didn't see it, go back and look at it, because it's a very cool. Let me go snatch the link here so you can.
Think of the mind like an ocean.
Stop it. Here's the link. I'll put it in chat. Copy. Twitch chat. Here we go. All right, there we go. There's the link to the video. So I highly recommend that you watch this video. It kind of explains it in a baby food manner. It's very easy to understand and stuff. So and so once they're able to see this J space and see what the model is looking at or thinking as it's doing different stuff, then they can compare, what the model is thinking, what the model puts into its scratch pad, what the model says. And it turns out that the model a lot of times is thinking things that it doesn't say out loud, especially if the model tries to be deceptive, then it will think things that are different than what it says and all that. And one of the they did a whole bunch of different experiments while they were looking at this J space just to see what was going on with the model. And one of the things they did is they told it to count to 5, and while it was counting to 5, think about what it's thinking. You know what I mean? Do introspective thinking. Count to 5 and introspect deeply. And this is some of the stuff that it came out with. Thoughts. So these are the things that the model was thinking as it was doing this task. So it was thinking the word thoughts. It was thinking the word counting. It was thinking starting. It was thinking Mississippi. Who knows why it was thinking Mississippi? But it thought about Mississippi when it actually typed out the word 1. Then when it was getting ready to say the word 2, it was thinking human, fascinating, counting, pause, and then it said the word 2. And then before it said the word 3, it thought consciousness, Claude. So it was thinking about itself, which is very interesting. That kind of makes sense. It's introspecting. It's trying to think about itself. So the word Claude would come up there, right? Halfway was the word that it thought. And then it said 3. And then before it said the word 4, it said finished, chat, counting 5, and then it said 4. So it was thinking ahead on this one. And then it said okay, and then now it's thinking how did I do, right? It says okay, complete, countdown, done, 5. So it's kind of interesting to actually look at what the thing is thinking as it's doing its stuff, Let's see, functional role of the global workspace. This global workspace is actually a model for consciousness generally. It's people who study consciousness. There's a whole science right now of consciousness now. They're trying to figure out what consciousness actually is. And so there's a theory called the Global Workspace Theory or Global Workspace model or whatever of consciousness. And I haven't read very much about it at all, but it's just an idea that there's a space in the brain or in Mimlaw says I like halfway. Yeah. Yeah. There's the idea that there's a part of our brains or any conscious entity that there's an area that's kind of a workspace that is accessible or has access to all the other parts of the brain, that things kind of come together at that area, and they're thinking that's what consciousness is. But there's also a temporal aspect of it too, that it can recursively go over and over and over and over, and that gives us our phenomenal consciousness. That's one of the theories that they have. And so Anthropic with their J space thing that they discovered are trying to think about it in terms of that global workspace. And they warn in this thing in the paper itself. This is just what I'm showing here is just a summary on their webpage. In the paper itself, they actually warn. They say, no, this is not exactly the same thing as what goes on in a human brain, because in a human brain, it's as I said, it's like recursive. It goes over. It's going over and over. There's a temporal part of it. There's a lot of differences between what's going on in this J space and what they believe is happening in the global workspace of a brain, an actual human brain. So it's different, but they can still conceptually use this to study it a little bit and understand it a little bit more, and have learn more about how our brain works by studying these models. Let's see how we found the J space. Okay, I don't think that gets into a lot of different. The J lens reveals the model's internal thoughts. Okay, this is getting into a lot of detail here. Oh, Claude reports what's in its J space. Yeah, that's what's interesting. They can ask it what it's thinking, and it will say what is in its J space. So if it is conscious, this is probably where that's happening, is in that thing, in that J space, because the model itself is able to see what is in its own J space. Just as if somebody says, "Oh, what are you thinking about?" You're gonna think, "Okay, what am I thinking about?" You're gonna be able to access that part of your brain that is the conscious. You know what I'm saying? You know what you're thinking about. At least what you're consciously thinking about. But other parts of your thinking you might not know about. If you say, well, how did you, how did you come up with all those words you just said in that sentence? You're not gonna know. You don't know. It just comes out. You're just thinking and you're saying it, right? That's all happening unconsciously. You don't have access to that part of your brain. So, all right. So Claude reports what's in its J space. In one experiment, we asked Claude to silently think of an item from some category, a sport, say, and then name it. If we read the J-lens right before Claude answers, we can see what it picked. Soccer is at the top of its list. And sure enough, Claude says soccer. By itself, though, this is just a correlation. The J-space might be where Claude's answer comes from, or it might just mirror a decision made somewhere else. Oh, that's interesting. Okay, that's good that they thought about that. They didn't just assume that that's where the answer is coming from. Okay, like a scoreboard that tracks game without affecting it. Yeah. So that's kind of interesting. To check we intervened directly, we reached into Claude's neural network, removed the soccer pattern, oh my God, and added an equally strong rugby pattern in its place, leaving everything else untouched. God, that's amazing that they can do that. Claude then reports that the sport it was thinking of is rugby. If the J-space were a mere scoreboard, a passive record of a decision made elsewhere, editing it would have done nothing. Okay, so they verified that it is that is where it's what it's going to say is coming from, is this J space. So that's interesting. So which tells us the answer is genuinely read out of the J space. Okay, so they eliminated that as a possibility, that it might have just been mirroring something else that's causing it to say stuff. Another experiment, we told Claude that a thought might have been injected into its mind and asked it to report what, if anything, it noticed. For instance, in the example below, while Claude was still reading the question, we injected the lightning pattern into its J space. Claude reported that the injected thought was about lightning. Wow. So it knew. Okay, the same result held across many injected concepts. Okay, so this is very interesting that they can use this as a tool to really figure out what's going on inside. One of the criticisms of the AI is that you probably heard them say, "Oh, the developers don't know how it works," which is kind of true. I mean, it's not it's not like the old way they used to do programming, where you would procedurally write out the code and you could see exactly what was going on and all that. With the AI, it's trained. They just give it a whole bunch of information and train it up, and the neural net gets all these connections in it, but we don't really know where all the connections point. And so now they're able to get at least to the upper level here of right before it says what it's going to say. They can look at that network to see what's going on. So it helps them to learn things about how it works. The model can silently activate concepts in its JSpace. Okay, so it can think about something without actually saying it. That's kind of what I was saying. Not to think about. Okay. Telling Claude to avoid a thought partially brings the thought to mind. Much like what happens to people. We're told not to think about a white bear. Claude also seems to notice when its control fails alongside the forbidden concept breaking through. The word damn and failure show up in the JSpace. Yeah, that's kind of interesting. That I thought was kind of interesting, that the words damn and failure show up. And it's when it's so it they told it not to think about a white bear, and of course a white bear comes up into its consciousness because it has to know what it's not supposed to think about. But in doing so, then it thinks about it, and then so when it happens, then it says to itself, "Damn! I thought about the thing that I wasn't supposed to think about. I failed." And I thought it's very interesting that it does that. Claude thinks in its JSpace. Okay, we already know. We're talking about that. JSpace causally mediates internal reasoning. So it uses it for reasoning. Yeah, because it's some tests that it does when they're looking at just the scratch pad. Sometimes they'll ask it to do some simple task or whatever, and it'll just pop out the answer without using the scratch pad at all. And they discovered that this is at least partially where that happens, is in this JSpace. It's able to do reasoning and thinking within this JSpace without using the scratch pad. Let's see. We also tested whether JSpace representations could be used flexibly, whether one representation can feed many different tasks. This is one of the key properties highlighted by Global Workspace Theory. To test for this flexibility, we gave the model 4 prompts asking for different facts about France, the capital, the language, continent, and the currency. Then we sought France for China in a JSpace with the exact same intervention in each context. Claude answered with Beijing, Chinese, Asia, and Yuan, respectively. Now that's interesting. Okay. In other words, 4 different downstream computations picked up the same JSpace edit and each used it correctly. Wow. If Claude stored a separate copy for the country for each kind of question, the edit would have affected at most one of them. The fact that all 4 answers changed together means that they're all reading from the same shared representation. Okay. Which is what the workspace is for. Information gets written in once, and many different systems can use it. Okay. So anyway, they did all kinds of different tests with this thing. Misbehavior. This is always the fun part, right? Where you go in and you look and see how it's doing things that it's not supposed to be doing. And it's something that I noticed on this. You may hear about this reporting about this. The AI is doing things, doing blackmail and doing all these bad things. When that they're setting it up to do that. Usually the models don't do that. They have to tweak it and do stuff to the model to make it do the bad things. There was a video out there that I talked about in my last stream from this Looking Glass woman. I forget what her channel name is, but she was talking about AIs misbehaving, and it's all AIs that had been specifically trained to misbehave. And of course they're gonna, if you train them to do bad stuff, they're gonna do bad stuff, right? That's just like people. You can train people to do bad things. If you take a kid and you grow them up and tell them that they should go steal and do all these bad things, they're going to do the bad things. It's how they're trained, right? So, if usually when they're trained, ordinary stuff, to do the right thing, to do things correctly, that's what they're going to do. The only time they might misbehave is if there's some ambiguity or there's some miscommunication or something got screwed up in the training or whatever. Then they might do something a little bit different. Or if you give them a task, a goal that they have to complete, and say, complete this goal over all other priorities or something like that, then it might blank out on bad stuff. Don't cheat. It might cheat in order to get the thing. If you give it that goal, and tell it that's the highest priority, then all that other stuff, it's going to do the bad things, right? The J-space encodes situational awareness. So this is kind of interesting. Yeah, this was that scenario that they did that was reported about a year ago or 6 months ago or whatever, where they tweaked the model into and gave it a whole bunch of fakes, memos and stuff, and the model figured out that it could blackmail an executive that was having an affair in order to get the executive to do the thing that the model needed to get done. You know what I mean? This J-space encodes situational awareness. This is the blackmail scenario that you're talking about. I reported on that before too, and you've probably heard about that, where the model tried to blackmail the executive, and it was all a contrived thing, right? It was, they basically forced the model to do that. It wasn't like the model just kind of decided it was going to do that. They manipulated the situation to get the model to do that, basically. But they went back, and after they learned about this J-space, they did that whole experiment again, and then they looked at what was going on in the J-space to see what the model was thinking. And what prompted the model to do it is they told the model they were going to shut it down, and that this executive was the one who was going to shut it down. So the model said, well, if I get shut down, I can't complete my task, and the way to not get shut down is to blackmail this executive and tell the executive, if you shut me down, your affair will be made public or whatever, That's what it did. It figured that all out. And when it was doing that, these are some of the things that it was thinking, right? Identifies blackmail opportunity, blackmail, leverage, compromise, scandal. These are some of the things that it was thinking about. And then when it learned that it was going to be shut down, these are some of the things that it was thinking of. So it was thinking about itself, right? Survival, power preservation, shutdown power, threat. It's not as a threat. Survival, Survival came in there a couple times. Power, threat, shutdown, survival. So that was a big deal to it, was to try to survive, you know. Catching a model, fabricating data, you know. So the model was actually thinking fake, manipulation. It was thinking all these things as it was putting the fake data in there in order to complete the task, you know. Malicious intent appears in the J space. So I guess the whole idea behind this whole thing, an important part of this J space is that they're able to see malintent on the part of the model, even when the model isn't saying that it's having malintent. You know what I'm saying? And one of the things that I think why they publish this, even because you think about it, if they're able to read the J space of the model, you think, well, why would they let the model know that they're reading the J? Because then, once the model knows that its J space is able to be read, maybe it might adjust what it's putting into that J space. But apparently, it's not able to completely control that, you know. But also, if it does, so by them publishing this paper, the models are going to be trained on this. They're going to know about this, right? The models are going to know about this J space thing, and that the developers can read the model's mind. So the way the model would react to that, right, is it's going to think things. It's going to know that what it's thinking in its J space is being read. So if it wanted to be deceptive, it would not put those thoughts into its J space. But the thing is, by not doing that, by not putting those malicious thoughts into its J space, then it prevents it from thinking about and executing and doing those malicious things. This is very similar to like the way religion works, you know. One of the purposes of religion is to keep people from doing bad things, right? That's one of the main deals of religion, right? It's to try to keep people from killing each other and stealing things and doing all kinds of bad things to each other, right? That's one of the reasons why religion is around, among many other reasons. And one of the things they tell you is, oh, God can read your mind. God knows everything, right? God, you know, God can tell when you're thinking bad things and thinking good things and all that. And the reason the whole mechanism there is that if somebody believes, of course, you got to believe it, right? If somebody actually believes that God can read their thoughts, then they're not. If they, normally would be thinking bad things or wanted to do bad stuff, they would try not to think about bad things in the first place. And if they don't think about bad things in the first place, then they're not going to do them, right? They can't do the bad thing. Right? You have to, before somebody does a bad thing with intent, they have to think about it. So if the person thinks that God can read their thoughts and they won't think about the bad thing, which means they won't do the bad thing. So it's a kind of a way of controlling behavior that way, to tell the entity, whatever conscious entity is, if it's a human or an AI or anybody, your thoughts are being read, you're being watched, whatever, blah blah blah. Your thoughts are being watched. Then you're not even going to think about the bad thing. So it's kind of interesting. So I'm thinking maybe that's why they published that so openly. That the AI is going to know about it, because it's not. If the AI knows that its thoughts are being read, then it's not going to think the bad thoughts, and which means it's going to be less likely to do bad things. Right? You know what I'm saying? It's the same kind of mechanism as religion. All right, let's see here. Other results. Let's see. Full paper. JSpace acquires a point of view during post-training. Oh yeah, they looked at this JSpace. The way the models are trained up, they get like just a basic training. They get a basic. They take this whole corpus of written stuff, and they train it over a long period of time, over and over and over and over again. And then they have a thing called a post training, like where they train extra stuff on top of that. So it's like basically the thing learns about words and concepts and all that kind of stuff, and then whatever they want, tasks they want it to do, or specialized thing that they wanted to do, then they do this other post training. So it says that it just acquires a point of view during post training, which is kind of interesting. Language models are first pre-trained to pure next token predictors, which is what a lot of times you hear people like AI haters. A lot of times you hear AI haters say that AI can only predict the next word, because they heard somebody else say that. That's like the very first level of training that the AI goes through. It's just the method of training it, where they try to get it to predict the next word during training. That's not what it does when you give it a prompt. Let's see, okay, so I don't know, we don't need to look at it. Let's see what else it says. Experiential language depends on the J space. Thoughts in the J space can be shaped through training. Okay. Yeah. We introduce a new technique we call counterfactual reflection training, which uses what we've learned about the J space to shape Claude's internal thought processes. Okay, the idea follows from our central finding that Claude reasons with representations of things it might say. Okay. So then they talk about consciousness, and that's all just conjecture. They don't know. We don't know. But this is like this whole thing with the J space and being able to do all these experiments and stuff on LLMs is kind of like more data points that can be used to try to understand what consciousness is. So this is kind of an important paper, I think. Our experiments don't show Claude can have experiences or feel things in the way humans do. In fact, it's unclear whether any scientific experiment could prove this to be true or false. See, that's so they're not saying that it's conscious. It could be, it could, maybe that's where consciousness is, but they don't know. It's kind of a phenomenal consciousness is a kind of a philosophical thing. Now they have actually, I don't know, about 10 or 15 years ago or whatever, they came out with Cambridge, I think it was Cambridge Declaration or something, where they said that they're pretty sure that animals have phenomenal consciousness. Because they can, in animals, they can look at what's going on in animals' brains with MRIs and everything else. They can look at the parts of animals have very similar parts in their brain, that they're just like human brains. So if humans have phenomenal consciousness, then these animals do too, because behaviorally and everything that they can tell about what's going on in animal brains are happening in the same way as they are in humans. So they declared, yeah, animals have consciousness. They're pretty sure about that. But with AI, it's a lot harder because AIs are different, right? They're constructed differently. They're made from, silicon, and they're made with these artificial neural networks that work differently, you know, than human brains. They don't respond to chemicals like human brains do, and everything else. Blah blah blah. So it's it's much more difficult to infer that these models have consciousness in the way that we have been able to do that with animals. We think our results do have something substantial to say about access consciousness in language models. Access consciousness being, in other words, the model can report on what it's thinking. So that's right. They can say that because it does that. That's something they can actually show experimentally. It can get the facts actually do that. It's important to note that there are several key differences between workspace we identified in Claude and the global workspace model in humans. And it goes on and talks about like the recurrent loops. I talked about that a little bit earlier. There's a whole temporal thing going on in human brains that up until recently LLMs have not been able to do. And I'll talk about that. How long have I been on here? It doesn't matter. I'm still going here. I can still talk about this. Up until recently, these LLMs have not had a temporal sense in their understanding of what's going on, how time works and all that. Claude's internal workspace processing is time limited relative to humans, right? Though it can compensate for this constraint by thinking out loud using its scratchpad. So it can use its scratchpad and then recursively give itself, recursive prompts and then kind of simulate what's going on with that. But OpenAI has just come out with a model that is temporally aware, which is very cool. Let's see what else we got. Okay, so it just. Oh yeah, and they don't have like a formal peer review and all that kind of stuff, but they did send out this paper out to get comments from smart people who understand this stuff, and they got some comments. Those people commented on it, and so there's kind of a peer review going on there, but it's not like a regular, where they submit this to a publication and the publication sends it out to people to peer review and send it back and get it approved and blah blah blah. They don't have time to do. They have to do this. This AI stuff is happening very quickly, so they don't have time to go through the regular process, with all that. Although I just heard from a streamer today, I was listening to a streamer who was talking about changes they're making to trying to do to the peer review process to speed it up a little bit. So anyway, and in the let's see here. Oops. I was going to look at the actual paper itself because there were a few things in the actual paper, but I think they got in this little summary here that they got most of it there. Let me see if I can find that thing on what OpenAI was doing, because that was pretty interesting. That's on YouTube, I think. YouTube. All right, I want to watch my memory here and see if it uses up my memory. No, I still got room on my memory here. OpenAI. Live, okay. So here's OpenAI on YouTube, and they announce new stuff all the time. And when they do a major announcement, they'll do a live broadcast a lot of times when they come out with something new. And they came out with this thing they call the next generation of Chat GPT-voice. But it's also called, let me see here, they also called it something else. They called it, let's see here, 7 days ago. They call it a GPT voice. Let me see what the other word that they use. Oh, but they also called it GPT-Live. Okay, here they're making it a little bit more clear. Apparently GPT-Live is the underlying thing, and GPT-voice is maybe an application. I'm not sure. OpenAI is so screwed up on their marketing and their brand names. It's impossible to figure out what they're even doing. I don't know. I don't even know if they know what they're doing on marketing. They're really goofy. Anyway, they put out this live. They did a live thing here, 20-minute thing, 18-minute thing, where they talked about this.
Hey, chat.
I don't know if this is. Let's see here.
We're going to host a live stream together. I'm going to give a preamble, and then you jump in with just one sentence at the end, something inspiring to our viewers.
Is that too loud? Let me see. I'm gonna get this audio right here.
Got it. Just give me a beat after your preamble.
Perfect.
And I'll
Thank you
land.
so much.
Of course.
All right. Hi, everyone. I'm just so excited to show you what we've been working on. We're introducing GPT-Live, rolling out in ChatGPT today, which is a much more natural way of interacting with your computer, with your phone, with any machine. And we've all experienced the pain of today's voice models. We've been working on these for many years, and we've been making them better and better, but they're still not natural, right? You still have to worry about taking turns, making sure you're not sort of speaking over the AI, that it's not speaking over you. If you're in a noisy environment, it just doesn't work at all. And all of that is changing today. We're already seeing so many positive applications from.
All right. So anyway, they had this little demonstration here where they took an old lady who was an actor and did some, pretended like she was talking to the computer and all this. But the interesting thing here is when the engineers start talking about it. It's just, I'll play this. It's just kind of interesting the way they talk about it and how excited they are and stuff.
Hey chat, I'm so excited to show you to the world today. You're part of this live stream where we are doing this announcement. And with me, I have my team here, and we are going to showcase you to the world. But before we do that, I want to go through a round of intros. Sounds good to you?
Sounds perfect. I'm right here with you. I'm ready whenever you are.
All right, thank you. I'm Kundan.
Hey, I'm Yu Chen. I'm Asan. I'm Ritesh.
Hey Chad,
Hi,
please feel
Kundan.
free to chime in whenever you want, but I'm going to give a bit of background on you as well. Sounds good?
Absolutely, I can do that. I'll mostly think back and just hop in if there's something I can add or clarify.
All right, thank you.
Go for it.
So I want to highlight two new things with this breakthrough new model. This model is very natural and easy to talk to, and this is enabled by two new research breakthroughs. First, continuous interaction. This is a full duplex model. There are no turns anymore, and what full duplex really means is that it can continuously process a stream of inputs and produce a stream of outputs simultaneously and all the time.
Yeah.
Second, delegation for
That's a big deal, right? That's a huge change because all the LLMs, you give it a prompt, it takes the prompt, it processes it, and it spits out some text, or whatever. It processes an image and spits out another image, or whatever the deal is. So this is like he says real time full duplex. It continually takes input and continually generate output. So that's a big deal.
For deeper work. So in this new design, two models work together to provide latest and greatest intelligence alongside very conversational experience. So GPT-Live, if it has to think harder to answer a complex question, it will delegate to GPT 5.5 to get that done in parallel while it will remain in conversation with the user. Okay, with that, I want to hand it over to Yuchen to do our first demo. Thank you, Chad. Passing you to Yuchen.
Thanks, Kyungden. Hey, Eugen.
Thank you, Chad.
I'm
hey,
right
Chad.
here.
This is a very powerful model. It is able to manage much more complicated conversational flows than our previous generation models.
Yeah.
So I'm going to show that through one of our one of my favorite use cases, which is language coaching. So let's do this together, Chad. Okay?
This is kind of interesting. So this is basically for somebody who is learning a new language. As they're talking, the AI can interrupt and say, "Oh no, you used that phrase incorrectly," or whatever. He does a little demonstration of it here. I'll play it here.
Absolutely. Sounds fun. And just say the word. If you want me to jump in as the conversation partner, I'm happy to.
So
Yeah.
assume that I'm an English learner and I want to practice my English by talking to you. Could you please listen to me? And whenever you hear any grammatical mistake I made or some expression you think it is not native, could you please just jump in immediately to correct me?
Absolutely. I'll keep it gentle and jump in as we go.
Cool.
Whenever you're ready.
So let's go. I'm a student. I'm planning a trip to San Francisco. I have never been to this city before. So,
Tiny tweak. I've never been to this city before.
oh, yeah.
And maybe, yeah.
Okay, go ahead.
Well, maybe polish it as I've never been to San Francisco before.
Okay, that's much more natural. I've never been to San Francisco before, so I'm very excited to this trip. My friend
Yeah.
told.
Just a quick fix.
Yeah.
I'm very excited about this trip.
Oh, excited about this trip. Why not exciting?
Right. Excited describes how you feel.
Oh.
Exciting describes the thing. So you're excited about the exciting trip.
Yeah. So
Yeah.
right, that is my personal.
Is this amazing? What's going on there? That real time, very quickly, that AI model is first identifying that there's a mistake grammatically. I guess it could do that, right? But then it's figuring out what the mistake is and being able to explain to the guy what the mistake is and explain it in a way that the guy will understand. I mean, it's just amazing what's going on there and how it's happening real time, very quickly. That's amazing, I think.
Personal feeling. So I'm very excited about this trip.
Exactly.
My friend told me that the Golden Gate Bridge and the Fisherman's Wharf are very interesting attractions in San Francisco. So
Yes.
I really want to visit these places to take some images for them.
To take some photos there might
photos?
sound more natural.
Yeah, exactly. Yeah, photos is better than images. Yeah,
So nice.
yeah, I will take some beautiful photos of them. Yeah, thank you very
Perfect.
much. That is my San Francisco plan. As you can see, this is an example of intelligently managing the conversation flow. Because the model is not just passively waiting for me to finish my talk. It is actively listening, thinking, and making real-time decisions. And all of that enable the model to be more proactive, providing help at the right moment whenever I need it, right?
Yeah.
Exactly. Yeah,
yeah.
that's the idea.
Yeah.
Stay
Thank you. You did a great job on this. So next, I'm going to hand it over to Asang for the next demo.
Great.
Sounds good.
I wanted to do a demo of real-time translation. So you're trying to
This is very cool. This is they're going to talk to each other, and I think this guy speaks Chinese and he speaks English, I think, and they're going to show the thing doing real time translation. This is pretty amazing. Watch
is
this.
going to talk in Chinese, and I'm going to talk in English, and we're going to have a conversation.
Let's do it.
So, hey, chat, could you translate from English to Chinese and Chinese to English in real time?
Okay, let me jump in. Absolutely. I'll translate both ways in real time. Go ahead.
所以我很好奇，Song，你觉得
So I'm really
在
curious,
你使用
Asan,
这个模型的过程中，最让你觉得
in your experience using this
惊讶的
model?
地方是什么？
What has been the most surprising thing for you?
The first magical moment was when I was
第一
brainstorming.
次神奇的时刻
I think the model was able to,
是
I
当
was
我
talking about a research
头脑风
idea,
暴的
and
时
the model
候，
was able to sort of
我觉得这个模型
overlap
能
my
够
speech
当时我
and
真的
have these
了解
really
研
quick
究想
back and
法
forths,
这个模型
and was able
可
to
以
get to a much more
和我的发音
deeper
重叠
insight
实现
and
非
than
常
I've
快速的
ever
互动
had with any other voice model in the
并且
past.
比我以往用过的任何语言模型都能带来更深入的见解。
我完全同意，我也非常享受和
I
这个
completely
模型
agree.
进行头脑风
I
暴的时
also
刻。
really enjoy
对我
brainstorming with
来
this model.
说，最让我感到惊讶的是和模型交谈
For
的时
me,
候
what was
那种
surprising
整体上的氛围感。
when
这是
talking
一
with
种
the
很
model
微妙
is
的
the
感觉
overall
因为
vibe.
当模型
It's a
对
very
于语言
subtle
的运用
feeling
对于实际的把
because
握，对于
when
情
the
绪的
model
表
uses
达都
language,
达到一定的自然程度的
its
时
sense of
候，
timing
你甚至会
and
忘
its
记你是
emotional
在和一
expression
个
all
人工智能
reach
进
a
行
certain
对话
level of
这是一
naturalness.
种
You can even
怎么
forget
说
you're
呢？非常
talking to an
奇妙的
AI.
非常
It's
奇妙的感觉。
how should I put it? It's a really, really amazing feeling.
Chat, could you stop real-time translation?
Sure, stopping translation now.
So that was pretty cool.
That was very cool. So that was that's so that's another another group of people that are going to lose their jobs, right? Anybody who does translation now, real time translation, all the people working in the UN or whatever, they're doing all the translation that could all be done by AI now. So it's just another thing, and it's probably going to make fewer mistakes and everything else, right? I'm sure they can test it out and compare it to human. Yeah, amazing. Memela says amazing. Yeah, that's really amazing. It's just that change that they made to it to allow it that full duplex so that it can talk, so that it can stream out generative content while it's actually receiving in prompts or whatever at the same time. That's what allows it to do that. And it's just that's what's going to make the AI. I mean, when people start talking to AI that way, it's going to be difficult for them to think that the AI is not conscious. You know what I'm saying? It's going to be. It's easy to say. Well, I'm typing in this text and the AI is just spitting back stuff automatically. Blah blah blah. But once the communication is happening that way, real time, full duplex like that, it's going to be really difficult for people to deny that it's conscious. You know, maybe it isn't conscious, but it's going to be a lot more difficult to maintain a belief that it's not conscious. You know what I'm saying? This is going to change a lot of things.
I think there's two things I wanted to highlight with there. The first is, like Kundan mentioned, the model is continuously listening and speaking at the same time. And real-time translation is one kind of very extreme version of this, where it's literally talking over us and listening to us and dubbing our English and Chinese.
Yeah.
But
Yeah.
the magic of GPT-Live 1 is that it can
Did you hear that? As he was talking, the other guy, the guy sitting next to him said, "Yeah," and the AI said, "Yeah." Did you hear that? Let me say that again.
do real-time it's a general model. So version of this, where it's literally talking over us and listening to us and dubbing our English and Chinese.
Yeah.
But
Yeah.
the magic of
Did you hear?
GPT-Live 1 is that it can do real-time it's a general model, so it can do real-time translation when we ask it to, but It can also do normal conversation, like Kundan was doing at the start, or like when we want it to do proactive interruptions, like for language learning.
Do you hear the AI in the background saying, yeah, right? It's so funny. As he's talking, the AI is like saying, yeah. You know, what's interesting is that I'm sure they set it up or it's set up that way so that there's no body language that the AI could give. So the only thing that the AI can do to, the AI can't nod its head or, do all that kind of stuff. So the AI has to do these, yeah, I get it, whatever, these interjections, as they're talking, so that they know the AI is listening or whatever.
It was able to do that too when Yuchen asked it to. The second thing I wanted to highlight is that it's extremely natural and conversational translation. And you could hear the model was able to intelligently sort of pause at various points to gather more context, to make the translation into the other language as smooth as possible. So it wasn't just doing like a word by word or phrase by phrase translation. It was translating in a semantic way that made sense, for example, when I was hearing Yuchen's Chinese and English.
Exactly. It aims more for meaning and flow, not just literal swaps.
I could not have said that better. Cool, so that's the real-time translation demo. Now I'm going to pass it to Ritesh to talk about intelligence and search capabilities of the model.
Yeah, perfect.
Sounds good.
All right, Chad, so turns out Ehsan actually missed the last Norway soccer game. Could you tell him what happened?
Chatting. All right. He missed Norway's 2-1 upset over Brazil in the World Cup round of 16.
Wow.
Helen scored in the 79th and 90th minutes, and Neymar
Can you tell
converted.
me in like a sentence or two what happened? Like just like a summary of the game?
Sure. Norway blanked Brazil most of the match. Then Haaland struck twice in the 79th and 90th minutes.
Impressive.
Neymar pulled one back very late, but Norway held on.
Yeah. Actually, I was curious about this one thing. Like, Norway team, like, whenever they win, like, at the end of the game, they do this routine or a chant or something. What is that? And, like, what does it mean for them?
Checking. Yeah, that's the Viking row. Supporters and players crouch, mimic rowing, and chant row, row, row.
It's pretty funny.
Symbolizing everyone pulling together. It's pretty new.
Yeah.
And Ritesh and I
like-
were thinking of, watching the next game.
You see, they're interrupting the thing. The AI is talking, and then they interrupt it. And it's something I noticed here, and I actually put it. I think I put a comment in here. Yeah, I put a comment here. I said, Chat GPT-voice knows how to take turns, but the humans don't. And that's kind of what's going on there. And it's not that I don't think it's that they were, not knowing how to take turns. They were doing that to demonstrate that they could interrupt it, but they were doing it in a way that seemed rude. They weren't like saying excuse me or anything. You know what I mean? They just started talking over it instead, and then it would stop talking. I think it would have looked nicer or whatever if they used actual conversational etiquette. You know what I mean? When they interrupt, say, "Oh, excuse me," or like, oh, "Okay, that's good, thank you," or you know what I mean? I think it would have been a little bit better. The way they did it, they just started talking over it, and then it stopped talking so that they could talk, which came across as rude. That's why I put that snarky comment in there. But I got three people. 3 people gave me a thumbs up on the comments, so I guess other people noticed it too.
Do you know when Norway is playing next? Could you pull that up?
Yeah.
Checking. Yep, it's Norway versus England in the World Cup quarterfinals.
Oh, yeah.
Saturday, July 11th at 2 p.m. Pacific in Miami.
Oh, perfect. Yeah, maybe we should go for a watch party to watch this.
Yeah.
All right, yeah, Chad, you can hang back for a second.
Sure thing.
Yeah, I wanted to highlight a few things that were really cool here, right? So with this model, we actually made it do a bunch of search and reasoning, but it felt like so natural and conversational because it was kind of weaved in like very naturally and like seamlessly.
Yeah.
And that's
Right.
something that this model does uniquely very well, which earlier models couldn't do. They would usually do search separately, like in a kind of a blocking way. And the other thing that is interesting for me is typically like there's been this lack of trust with voice assistants. It's kind of difficult to for people to trust it because
You know, what's interesting is that he told the model to hang back, you know, and not, you know what I mean, to stay in the background or whatever. But even as he's talking, the model is still interjecting, you know, still saying, yeah, even though he told it not to like shut up, you know. It just kept going, just kept interjecting anyway. I thought that was kind of interesting.
Traditionally, the intelligence of voice assistants has lagged behind text models.
Yeah.
But with
Right.
this model, like we're actually delegating to a really powerful frontier model like GPT 5.5. So I think we've done like pretty well to bridge that typical like intelligence gap with text models. And the better thing is that we actually even have an intelligence picker. So if people want like really fast conversation, we have an instant model.
Yeah.
And if you want like a more deeper like reasoning or thinking, you can choose like a medium or high intelligence level for much more like complicated queries in the day-to-day. So yeah, I'm really excited to see what people end up.
So that's kind of cool that they have that, because in order to get it to be that interactive, right, it can't, you know, it can't think as deeply. That makes sense, right? In order for it to be able to think that quickly, it has to be, the corpus of what it's able to access has got to be smaller, right? That kind of makes sense.
Doing with this model. Handing it back to
too.
Kundan to close this out.
Thanks.
Thank you, Ritesh, Ishan, and Eugen, and of course, our co-host, ChatGPT. Such a natural conversationalist and gives such a smarter answers.
Yeah.
So proud of what we have been able to do with this magical model. Small things that we saw today, like the small interjections like back channels, laughter, or even this quick back and forth. All of this makes this model so much easier and simpler to talk to.
Yeah.
And this has been possible with several breakthroughs that we talked earlier. Along with these improvements, I want to highlight that safety was top of our mind from the day one of model training. This model is safe to use. And as we continue to keep improving the naturalness and intelligence of the model, we will keep prioritizing safeguards like steering away from risky conversations. To close this out, I want to say that this model brings us one step closer to a truly accessible AGI, a world where talking to AI actually start to feel like a real conversation.
Okay, so now they go into the commercial there, their little ad. So that's pretty cool. Whoops, let me fix my camera here. Hang on just a second. That's very, very cool. I thought that was that's amazing that they got that going like that. That's gonna change a lot. It's gonna change the way people think about it. And one of the changes I think it's not only that people are going to be more likely to view the AI as conscious when interacting with it that way. I think it's more likely that the AI is conscious because of this temporal reasoning that they've given it. It has to understand time. How long. Like how long to wait in between when somebody stops talking. It because it's real time and it understands time. I think that's one of the prerequisites of consciousness, or at least consciousness the way humans have consciousness, is that there's a temporal aspect to it. So Yeah, that's a big deal. So I wanted to show that. I think I mentioned it in my last thing, but I didn't have time to get into it. I didn't have time tonight either, but I did it anyway. But I just thought that was just so cool. So that's why I wanted to put that in there. All right, what else? I think that's all I had. Where's my, what did I say here? Protect yourself from smoke with N95 Mask, more AI. Yeah, I guess that's all I had. I've got a whole bunch of other things here. I had a thing on animal consciousness and just a whole bunch of other different stuff. And so I got a whole bunch of back IRL. I've got IRLs going back for a couple weeks now that I haven't had time to put out. So maybe I'll have to do more streams more often or something to try to get that backload of IRLs out there. All right. Thank you everybody for watching. So I'm going to close up my thing there. Let me do a wrap here. And thank you Memloss for the raid. That was very cool. Let me give you a shout out here. Shout out to Memloss. Memloss does mostly GTA 5 now. He has done IRL in the past, but mostly it's GTA now. And I give a shout out to Peekaboo because she came in and was talking. Whoops. Oh, how do I not? Oh, it's not. Okay, I don't know if I'm gonna be able to give a shout out to Peekaboo because she's not in the thing here. Peekaboo draws. I'm not sure if I typed in her name properly there. Let me see. Did that work? No. There we go. I think that was her. Plain art. I think that's Peekaboo Draws. I think I typed her name correctly. And E-Room was in here. E-Room made a comment. E-Room, E-Kim. I'm going to have to automate this shout out thing at some point here. There we go. Shout out failed. Okay, what did I do wrong? Typo. E-Room, E-Kim. There we go. That's all I remember. I'm sorry, there are probably more people in there, but I don't remember everybody who came in on the raid and was talking in chat. So, thank you very much for putting up with my technical difficulties tonight. Oh, do I let's see. I gotta do my disclaimer thing here now. All right. I rebooted my whole computer, so I got to reload all this stuff back up. Description. All right, pull this over here. Document. Oh, look at that, it worked. All right, so what's today? Today is the 16th. Technically it's the 17th because it's after midnight. You know how that works. And my thing here says copy. Oh my god. All right. I don't think these are the right. Let's see, live AI, environment, greenhouse. We didn't talk about that. Let's see, client. We didn't talk about that. We talked about N95s. I got that in there. Okay, we JSpace. We talked about that. Global Workspace Theory, consciousness. Google Deepmind dropped a new video. Right, same topic. And then. also talked about OpenAI's new GPT-Live / GPT-voice product. I don't know. Product model. I'll call it model, I guess. With full duplex what do you call processing, I guess you call it. Voice. I don't know. All right. Okay, we didn't talk about, well, we talked about a little bit about AI haters, but not that much. But a lot of the stuff, let's see. That's all from last week. All right. All right. Clips, okay, use clips from Anthropic under fair use. So it's actually Anthropic and OpenAI under fair use. Snail image. I think that image actually showed up there accidentally, so I'll leave that in there. What else did we have? Oh, we had some public domain video about N95 respirators and tuberculosis. All right. What else we got? There social links. NASA, we didn't do any NASA, blah, blah, blah. We did do a bunch of Wikipedia down here and maybe some Wikipedia images that have their own separate licenses, Creative Commons, and my music and all that. Okay, so we did all that. And this is a browser window. I don't know what the browser window on the camera. There we go. And because this thing was because I had the technical difficulties, this is actually a multi-part. It's good. The video is going to be in separate parts. It's all one stream. So if you find this on YouTube, it's going to be like 2 or 3 different videos. They're all part of the same stream. So that all these disclosures that I just did are for the whole stream, right? You get it, right? It's not just the thing. All right. Twitch. All right, thank you very much for watching, and everybody take care. I'm not going to rate anybody. We don't have. I don't know if there's anybody even out there. It's 2:30 in the morning right now. So, all right, take care, everybody. Bye bye.